That was, uh, is it Palindrium something? Yeah, so he stopped on side chain. Yeah, but the session was good. That's when I realized I didn't know most of it. Yeah, so I'm grateful I added something on my theory to the more research I had. Thank you.
So I think we better call Emma to finish the rest. Uh, Otherwise, today we are going to be looking at some new topics. So we're going to look at oracles. Um, so probably let me share my screen. Sorry. So what are oracles? As we have been saying, when blockchains want to talk to each other, blockchains are like these siloed islands. Each blockchain has its own infrastructure and they have their own way. So if they want to talk to one another, they already need some sort of communication between the two. So probably this could be between things like trustless bridges or things like um, yeah, some sort of proof. So maybe one blockchain bundles proof of a transaction and then the other one decrypts that proof. I think we talked about things like talked about such things when we talked of something like Marco trees, but they in they would need like sort of to talk to each other. So in a way, and one of the other ways that all those ways that I've been talking about trustless in a trustless manner, like trustless bridges or uh, through messaging or by some sort of coming to an agreement. Um, trustless means that they don't need any intermediary or everything is transparent. But they can also communicate between each other using oracles. All right. So here I have a list of decentralized oracles. So for the Alchemy Dapstar, among which we have Chainlink, band protocol. So band protocol aggregates and connects real-world data and APIs. We have create API 3, yeah, and then we have DAI. We have Python network. Yes, Python network is very common in so many chains. So high fidelity, high frequency market for DeFi application. We have Switchboard, UMA, SEDA, FairFi, and Flare Network. So they are really a number. Yeah, Chronicles. I was working for Chronicle Protocol. Chronicle Protocol is also one of the really most used oracles. Yeah, so their biggest use case is facilitating communication between chains. Let's say you have a token on chain A and you want to mint it on chain B. You can use an oracle. Maybe you want to have the same NFT across different chains. Yes, so oracles facilitate such things and more. So today we are going to look at one use case of an oracle, and then yes, we can kick off from there. So we are going to start with Chainlink. So probably let me share my screen and then. Otherwise, as we are moving on, let me take this opportunity to greet. How is everyone? I'm seeing Agre here. Yes, Prime, Arnold. You left the meeting. All right, I'm back. Yeah, so all right, I think I'm back. Paul is here. So I hope everyone is okay. And yes, okay. Sharing my screen. So you can search about Chainlink from chain.link. I don't know why. Yeah, I think Chainlink. Yeah, so Chainlink really has a lot on their development. So this is Chainlink. I think every day they are growing. Total transactions 19. I don't know, but yeah. Developers, then docs. I think this is the best place. Or developers, and then tutorials. So there's also facet, but developers, facets, Ethereum support. Yeah. So if you come here, unfortunately, if you say continue, if you want to get from this facet, the description request for native tokens require the user to hold at least one link on Ethereum mainnet. So if you don't have one link on Ethereum mainnet, have nothing on Ethereum mainnet. Having the $1. So Ethereum mainnet. Ethereum mainnet has gone down real high. Huh? Hodlers of Ethereum. I should cry. Okay, so yeah, you should have one link token. I think I might not need a link in this session, but in the next session I will have at least some link tokens. So, but as we are saying from here, also you can look at the tutorials. So Chainlink really has a lot of good use cases. So build up for Spotify stream-based artist payment, how to verify smart contract on Etherscan, build an NFT marketplace. I think this is really a good place. How to mint an NFT is simple. How to verify smart contract. This is a good place to really go through. And today we are going to just get one of the use cases of Chainlink. All right, so this is the address I use for testing. So I'm going to deploy on Sepolia. Let me check if I have, you should have some Sepolia testnet ETH. And yeah, so if I forget, we can go to the Rise Up. Mm. So yes, let's go to the Rise Up. Today we are going to be like doing together. So because we are really going to, I want us to be engaged. Um, as always, we are going to start with today's 12th of it is. So 12th of May 2024. So this we are going to start with name, and then X handle or X post. Yeah, please let's support each other. I encourage you, write your name, write your post, what you are learning or what you've learned about today. Yeah, and that will be, awesome. So someone is already typing. This is good. Yes, so we can push each other on platforms like X. If you're a person who uses LinkedIn, let us know. Yeah. So that's the Rise Up. If you don't have access to it, I can share it in the. Let me share it right here. Okay, I don't know. I think I have. Did I click on something? I'm getting subtitles, so. So I think. Okay, I've seen the issue. Yes, so yeah, I've shared the link. So please share your X account, share what what you've posted. Let others. Okay. And then I think here I can add on the LinkedIn. So LinkedIn username, all post. This is a good way to all right. So today what we want to do is we want to create our own token and then have a token shop for it, and also determine how much each token of ours is bought. So that's what we are going to do first. So when you go to Chainlink documentation, there is what we have here. We have CCIP, which is cross-chain. Is it interoperability protocol? Something cross-chain protocol. So There's data feeds, data streams. So data stream is when you need data in live, in real time. Data feeds is, for example, what's the price of BTC to USDT, or ETH to USDT, or ETH to Link, or Lisk to ETH. Yes, so if you want data feeds, that's the oracle that keeps fetching. And we also looked at, we are looking at Chainlink, at dexes, and we saw how these prices come to be on a small or beginner level. So VRF, if you want randomness, you're creating a game, automation, if you want maybe, I think we shall look at these as we move on. So today we are very much interested in data feeds. And so here you can get price feeds. So really I encourage us to go through these docs types of data feeds: price feeds, smart feeds, rate, rate volatility feeds, L2 sequence uptime feeds. You have to learn how to use L2 sequence uptime feeds. Okay, components of data feeds. Alright, so we have even these components where we have aggregator interface, V3 interface, and we are going to be seeing these in our smart contract. So I encourage us to come, take time, go through the docs, and yeah, this is just introduction to it. What's this thing doing? Okay, so here when you have get started using data feeds on L2 networks, before you begin, example, this is really some good documentation. You can open Remix and just think around with it. Price feeds, so we need a lot of price feeds. Chainlink data feeds provide data segregated for many data sources by a decentralized set of independent node operators. So however, there are some exceptions where data for a feed can come only from a single data source, or when data values are calculated readings. Like read the selecting quality data feeds to learn about. Yeah, so yeah, so I think with that we are going to really focus on that. So let's get started. Um, we are going to use Remix. I think today we should use both Remix and Foundry. So I think in the next session we use Foundry and test our code. Otherwise, so yeah, we are going to have a token and then a token shop for it. So yeah, ERC20.sol. Let me name this ERC1. Is it Bude.sol or Decentrac or Decent.sol? I encourage us, please. You can give us a few minutes. Let everyone pick their machine. Today we are going to really be engaged. I want that after here, after this, if you deploy, you share your smart contract that you've deployed. I don't know what to put C. So down right here, I'm going to put name and token address of the deployed token, deployed ERC, the deployed token. So yes, let every one of us, get their machines, be part. Okay. mwagala kujyawo projector zimanyi oba ku ntebe birekewo wano birekewo hope yeah we are all ready to deploy. So let me share some so in the rise up so start so when you check in the rise up, I think we have did I name it descent.sol? Descent.sol. So between the start and the end, you can also mint an ERC20 token, but from OpenZeppelin. But here there is something that is very crucial. So okay, I think we can go through the code before anything else. So mainly what this is doing is, first of all, this function decimals public pure override, so return your int this the number of decimals. So like the way you see a stable coin or USDT or normal fiat, which is to 2 decimal places. So this will convert our token to have 2 decimal places instead of 18. Okay, so we import OpenZeppelin as always, not as always, but if you want to do an ERC20, so you have to import it so that you implement the functions. And yes, access control will help us to grant roles. So probably can grant roles the minter role to an address or to a smart contract. So that's the biggest thing. So this was what I did. Can change it. So this is dct. I think I can also change it here. So dct, you can name it your name. You can give it Nuno token. Yeah. So grant, of course, Minter msd.sender is the deployer of the smart contract. And as we said, the difference between MSG, this is the address, this is the connected wallet address, but msd.sender is the address of the deployer. So function mint, of course, the minting function. So public only role. It's the same as saying that the minter should be only the one who has the minter role. And then, yeah, you can call the mint function to the address you want to mint to and the amount. So that's our ERC20. And if I save, so when you come here on our left, from our left where there is a home, file explorer, search files, so it a compiler. So if I click on Solidity compiler, you should check this. So when you check this auto compiler, it will automatically recompile your I don't know why. Yeah. So when you check the auto compiler, it will automatically recompile your Solidity code, automatically compile when you make changes and show you. Yeah, if otherwise, if you haven't checked it, you have to press Ctrl S or come here and press compile. Okay. Then after compiling, we are going to deploy. So you go to the next one, which is deploy and run transaction. Then there is a debugger. Then I have a sorting testing. So this these are plugins that you can add. And no, this one is there. You're sorting testing. By this learn ETH and contract verifications, I added them myself. So let's continue to deploy. Before you deploy, you should make sure that you are an injected provider. Today we are going to deploy on Sepolia, so I would task you to deploy probably L2 after this, such as Lisk Sepolia or something else. So making sure that, or ensuring that we all have some testing nets. I have 0.023 Sepolia ETH, and here instead of I'm also on Sepolia as my chain, so here I'm connected on Sepolia. Then here I can simply put injected MetaMask, and yes, it is loading here. And so we have Sepolia, which is 111555111. So that's the Sepolia network. So I'm going to click deploy. Deploy. And yes, I don't know why of recent there is always this issue that gas estimate error, but you can say send transaction. And once I click send transaction, oh my god, this is too much gas. I don't think 0.3. So I think there is a very huge error in estimate with remix. Let me deploy again. Maybe I can say decent. And compile. So But then I don't know why it is really giving me a lot of gas. Creation of descent is pending. So gas required. Here I'm going to put point 21. So okay, someone is going to bail me out. Copy address and then Telegram. Okay. So let me put, where should I put down? Okay, so let me just put under here Concourse and then my wallet address. Okay, so that's my wallet address. So there's one thing I sometimes find funny, which is when I deploy with Foundry, it seems I use less gas than Remix. However, so I don't know why that is, but it seems like even if I have very little gas, the thing just deploys on Foundry. Yeah, thank you. So I have gas now. So I don't know why this is taking me more than. Okay, let me reload. So descent, that's all. Save, and then injected provider. Okay. Is it that many people are using internet or I am cooked? So okay. continue here. So deploy. Creation of decent timeout. So let me do it one more time. So at last, um, confirm transaction. So the contract has been deployed. It is here. We can look down, balance off, approve, and minter rule. So that's the minter rule. Okay. So now we can let me share my smart contract. So this is the token, which is called decent. Let me share it in the rise up. So I'm looking for more names here. This one is just statement. Now for me to have this token as part of my listed tokens, or even any wallet is token, I can come here and token import. So I add the address of the token. Next, import. Okay, let me import. On what? So like the way you can have another token such as USDC, USDT, or something. So I can have this token or link token. I can have this token as part of my tokens, or you can also make it part of your tokens. So the only thing you need to do to make it a part of your tokens is to come and copy the address, the token address. Then I go to your MetaMask. Maybe I can go to another MetaMask. So maybe say this one, and go on Sepolia, so since it is the network, if it is on mainnet or anywhere, so you go to that and then import it. So if I paste it here, see it brings the DCT, which was decent, and then the tokenless Moz, which was part of the so if I have these tokens and I send it to this wallet DCT, then yeah, can be imported. So I wanted to import it here under Sepolia as one of the tokens. So if you have minted it on mainnet, you can also have it under your mainnet. So yeah, if you've deployed successfully, please put your address in the rise up. Are people deploying? Oh, we move on. You've deployed? Okay, so let me see those that have deployed in the rise up. We have Manuel. I think this is a good place to tweet something and let us, repost it or something else. So yeah. Um, so this is good. Now let me put also the here it is reconnecting. Okay, so I'm going to also have a shop where a token can be purchased. Why my rise up is not responding. So funny enough, I've added some code. So if I added code in a different place. No, no changes. Okay, I mean it as I add the code in the riser. Thank you so much. I don't know whether it is internet or something, but I'm almost starting to take off some. All I think I should use a cable. Let me see if I can. Yes, otherwise, yeah, today we have been having Arnold on site and it has been a pleasure. I think seriously we should often have these, but yes, great to meet you, you know. Yeah, so um, hopefully we can see. So please, as he has advised, you should know what each line of code does. If you copy and paste and your rag pulled, uh, but yes, I don't know why this thing isn't responding, but for what it is responding, we can copy from the start to this place before the name. So this is our token shop and we are going to go through it line by line. I've not yet seen Maria's deployed address. Alright. right. Yes, Mr. Damba. Are you on the computer or you will follow later?
Come on, I'm almost done.
Yes?
I'm almost done. I'm going to share my address.
Okay, okay, okay. Awesome. Mukulu banaye. Thank you for the visit. Hey, next time, we really appreciate anytime. I don't know how you went through the thick and the thin, but good to have you here. Let's keep sharing opportunities and whatever comes by. Yeah, guys. Neyongereyo omusajja muwerekere. Oba maybe one person can really. Okay, thank you. Ciphering updraft. Sajja wandimuwerekedde wa mpewo y'eno wiiki yo obadde nnene. But yeah, we are pushing seriously. Agree. What next? Tochirwamu. But I'm going to continue really. Man, have a great time. Yeah. See you. Ha.
You know French?
Abasajja bamala kgenda ati mutugeya mutugeya
Mais merci beaucoup pour venir ici.
Pour la visite.
Oui,
Yes.
pour la visite. Merci beaucoup. Alright, bonne travel aussi.
Man, I'm losing network.
Really slow.
Kansooke mbaggyemu anti internet wenagizaako 14 gundi yagaanye okumpa ssente Sam yali angambye yateekako internet naye odeze batuwadde yangambye nkuwonye cause it's okay wandidde nnyo bano nga neebaka
Let me think this suppose.
abi musajja afube nakyala nkola emyezi 6 nga tebakuwa nosigala. Hello. Yes, I'm back. Had some internet outage. Hey Teddy, have you deployed? Yes. process, as we said before, that why I can repeat the process. Should I repeat the process? Okay, so we are saying that I want to sort of create a token shop. So when you go in the rise up, where there is today's date, so today is 12th of March 2024. So in this rise up, of course we've written the name and X handle, or also LinkedIn username or LinkedIn post. So by then we have this smart contract decent.sol. So you don't need to have anything like installed. We are using Remix. So you copy this up to the end. There are a few lines of code. It's an ERC20 token, so you can name it your name, like teddy.sol or something. Then you come here in your Remix, and under here files, you click here and create new file. Yes, Teddy?
Your screen is not visible.
Oh, sorry. Is it visible now? Okay, so as we said, you come to the rise up. There is a file called decent.so. Copy the entire code from start to end. There are a few lines of code. Then you go in the remix, and remix, you put in remix.ethereum.org. Then it will open remix, and you go here where there is file explorer. After the big home, then file explorer. When you click on it a second time, it will open up this, and then click on create file. Then name your smart contract, and don't forget the .sol, which is .solidity. So mine is named decent.sol, and then if it is not open here, double click to open it. If again you see maybe this screen, come here and click on the screen that is having your smart contract. After there, you leave the search, come to Solidity compiler, and then click on auto compile. After auto compile, it will automatically compile and bring the green tick, or click on this button, compile, or both. So after it brings the green, come down to deploy and run transactions. Then here on deploy and run transactions, here you have remix Kankan or another remix. Put injected provider, and yes, so for you to be on the exact network that I am, which is Sepolia, you have to first look at your MetaMask and change the network from which you are on. It could be maybe you on base mainnet or you on Ethereum mainnet. Change that network and move very far down, like to the last networks, where there is show more networks. If this button is locked like this, click it open, then you will see Sepolia and linear Sepolia. Click on Sepolia, and then yes, when you click on Sepolia, this injected will show this ID 111555111. And yes, ensure that you have testnet Sepolia. If you don't have testnet Sepolia, please paste your wallet address so that someone here can gift you in the rise up. Or so in the rise up, you could come down here below and then write like a comment, like here. Comment is like two slashes, and then put your name and your wallet address, the wallet address that you use for testing your code. I encourage us, please make sure that your wallet address that you use for deploying and doing smart contracts is not the wallet address you use for your real funds or real assets on mainnet, because you are prone to making mistakes with it. or exposing your private keys. All right. Yes, Nabuma Teddy, your hand is up. So are we together?
Sorry.
Are we together?
Let me try again.
Yes, I'm waiting for you to deploy and see a smart contract in the rise up. Pod Damba. Have you deployed? Ronnie Manji, have you deployed? Yes. What is the problem? What is the issue? So we are waiting for you.
Yes, Vian, I have just joined, but I think I'm catching up. But for this decent.sol, are we copying an empty something that has start and
So be,
SS down here?
so between
That's
start
all. Or will we copy up to these names?
no copy between start and end.
Am I audible?
Copy between start and end. Yes.
As if they're not yet deleted.
As if they are not.
As if they were deleted from the razor.
Somebody. Okay.
I
I
see
think
no
someone
copy.
cut it. No. So in the rise up from line 652 to line 600, from the line 652 to line 675.
Have you played it? I think I'm so funny.
Yes, 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 Teddy.
You see my razor? It's kind deleted. I don't know.
Yeah, okay, let me refresh and see. I think this is due to internet or Yeah, so somebody has done Control X. All. So let me post it again. Please, don't cut the code. Okay, let me copy it from my remix. This is decent.sol. Is it now available? Okay, so we are waiting for you to deploy. Uh, Hopefully you have testnet on Sepolia. Actually, you're super. Super.
Yes, it was her. Yeah.
Enda kumpa ndira musuku yeka.
Would you like to import this token for Sunday for
Yes. Now, should we continue? Have you deployed? Or you need some testnet tokens? Ronnie, have you deployed?
Yeah, who has some person token?
Yes?
I think I need some person tokens.
Okay, so if you need some testnet tokens, paste your wallet address. Yes. Paste your wallet address around here and yeah, in the rise up. This is a wallet address.
Oh, yeah.
Okay. Let me share. So have others deployed? You have sent. Ronnie, what's happening?
I am in the process. It is compiling. I think my internet is slow. Maybe the other question is, do we have to create a new project? Because now here for me, it has already these contracts. Other, I've not started from, I've started from the default. Now I'm deploying.
Which default? I think any RC20. Okay, Teddy, have you deployed? Mm.
medical number. My token is not, the network is not detected yet.
Why deploy ku list?
Sepolia. Could this
Anti olina okugimportinga under risk network. I think we can continue. So, as we said, after deploying, you will see down here the smart contract address of the deployed smart contract. So if I copy this and I go to my MetaMask wallet, and then I go under the Sepolia network. So this is Sepolia network. Uh, Under tokens, there are tokens that I imported. There is USDT and so on and so forth. So I just go to these three dots on my right under Sepolia on the most right. After sort by, there is three vertical dots, and then I click on import token. So to ask for my token contract address, then I can paste the copied contract. So, and here they are saying token has already been added. And the reason why they are saying the token has already been added is because I have added it previously, and it is this DCT token. Are we together? So let me continue. So what we are going to do next is in the Rise Up, we are going to have the token shop. So after the end, here can have token shop dot so this is another smart contract which will work as a means of purchasing our token, and start. So Ted, your hand is up. I think you can remove it. Okay. So I'm going the Rise Up, and I've pasted the token shop.so, and here we have end. So the token shop.so is starting from line 680 and then up to 747. So here in my remix, I can go under File Explorer, create new token, and then I have token shop .so. So in token shop.so, can paste my code, ask me later. And yes, So we are going to go through this code one by one. So we start with the Pragma version. When you look at this end.sol, it is 19, so we can also keep this at 19. So this contract, we deploy it on Sepolia, and we are going to know why, because first of all, we deployed our descend.so on Sepolia. So we have to call the Chainlink aggregator interface, v3 interface, and where does this come from? So in the docs, using data feeds, price feed, solidity, reading. This is the aggregator v3 interface. So to consume price data feeds, your smart contract should reference aggregator v3 interface. So yes, that is it. So it's that aggregator v3 interface that, or even if you want to get historical data, so the best place to go to is the documentation. So you see under here, you can get data feeds of different networks on mainnet and on testnet. So, but that's the main reason we import the v3 aggregator v3 interface. Then of course, this is the one that will help us, to pick the data between Ethereum and USDT. So we have the minting address, which is external, contract shop, token shop. Aggregator v3 give us the token, the price feeds. Then token interface, public minter. So the minter of this token will be the previously deployed token address. So token price, we are going to set one token to be equivalent to 2 USD. This will be set due to the help of the data feeds that are picked by the Chainlink Oracle. So yes, contractor address, token address, then minter. So on the networks, if the network is Sepolia, this address or price feed of the aggregator is given according to the network. And let me go and check that out. Think under resources, so feed addresses, price feed addresses. So networks, these are the Ethereum these are the main networks, and then on Sepolia. So we're looking at the Sepolia and the price data feed for ETH So um, ETH it's ending in 306, and when we come here, so this is the address for the price data feed, which is 306. So in our case, if you've deployed your smart contract on, let me say, another network like Lisk or Avalanche, so um, you'll have to get price data feeds of that chain or Stacknet. Here they are guides. So yeah, so for our case, we are deploying on ETH and that's why we have this. So if you wanted price data feed of Euro USD on Sepolia, then you can, just take another contract address. Is that understood? So here you can check different networks. There is Ethereum, BNB, Polygon, Gnosis Chain, Avalanche, Base, Metis, Moonbeam. So all these price data feeds, Hedera, can be gotten. So probably you would want, for example, I'm not seeing Lisk yet, so probably I think you could have deployed on another layer too. zkSync, Sonium, Metis, Moonbeam, Moonriver, wherever you deploy. For example, if I deployed on Celo and I check on Celo, so I'll have the mainnet data feeds and have the testnet data feeds. Okay, Tracy, please post your smart contract address in the Rise Up. Congratulations on deploying. Okay, so let's go back to explain our token shop. So price data feeds equals the aggregator v3 interface. Then you pass in the address of the price data feeds that you want. Then owner is the deployer. So then the function get Chainlink data feed latest answer. This is also a function that you can, these functions can be gotten from the aggregator v3 interface docs here. I don't know, that was somewhere where we aggregator v3, I think it was among the docs that we are reading. So yes, from here. So it's all about reading the documentation, because you get aggregator v3 and then you see how to get history data, and then the latest data function, get historical data. Yes. So here we have function get chain, we have called it get Chainlink data latest answer, and it is a view function. We are just reading from the oracle. So please, with this function, note that these commas are part of the parameters. So this is the statement, like the this comma is so what is this thing called? Yes, so comma is actually if I do it like this, yes, comma is there, int price. So this other comma is there. It is not just part of the statement. So Yes, it simply means, well, there is this, there will be nothing, comma, int price. So you int started at, there will be no time, and yeah, the historical price data feed dot latest round data, and return the price. So then function token amount, of course public view returns. So this will get the amount of ETH that you send to the smart contract, and then convert and then mint for you tokens that are equivalent to that amount of ETH, where one token is costing 2 USD worth of ETH. So if USD, now here we are converting where we get the amount of ETH times amount of ETH USD times 18, then amount of token is amount of USD over token price times 10 to power 8 over 2. This 10 to power 8 then over 2 is yeah, that's how it is. So 8 decimal places, and then divide by 2 decimal places. So you should have this receive external payable function, and the receive external, there is the external payable or the payable, and make sure that your smart contract is able to receive tokens. So in this case, your smart contract will have the capacity to receive the amount of ETH sent to it on the Sepolia testnet, and yeah, msg.value, and then the address that I sent these tokens will be minted. Tokens of this token type will be minted to the person that sent Sepolia ETH, and then modify only owner. So message sender should be the owner. If it is the owner, we continue. If it is not, then the entire program stops. Then we also have the withdraw function, which will allow only the person owning this smart contract or owning the token that is being minted to withdraw the ETH that has been sent to the smart contract. Okay, so after that, I encourage us, please, let's do a lot of practice. This is just to open us up about the capacity and capabilities of oracles. So we can come here and compile, but I encourage us to have auto compile checked, so that every time you just have your smart contract, it automatically compiles. Otherwise, if it is not checked, click on the compile, and we go on deploy. So when I come here on deploy, first I should check that I'm on injected provider and Sepolia as my network, and then here, so because our smart contract has the token interface, token interface as also a function, please here you make sure that you select token shop. So it has the aggregator v3 interface, token interface, and then the token shop. Select token shop before you deploy. Now here when I hover over deploy, it will not allow me to deploy, so it will be inactive. And what does it do? It is requiring an address. So the address is the token that it will be a shop of. So the token address is this address of our recently deployed token, which is two decimal places as we saw earlier. And then if I paste, even if I close now you see that it is active, that I can deploy. Even if I open and I click on transaction, there is the token contract address. So let me close and deploy. Creation of token shop pending. Okay, so let me sign with my wallet address, confirm. Creating of token shop. Yes, that's a good sign. And yes, you can view on Etherscan. This is the block number. You can also enlarge it here. But when you go down here, my token shop is deployed. Now, at this moment, my token shop cannot sell tokens because I should authorize it in my token. So when I come here to descend, which is my token, there is this minter roll. When I click on minter roll, so this is my minter roll. It's a byte 32. So if I come on grant roll, there is the row which is the minter roll byte 32. I paste it here. Okay, before I go there, let me first paste my minter roll in the rise up. So my minter roll, that is it, byte 32. Are we together at that point? Yes, I need a thumbs up. Are we already lost? Okay, so since there is no response, I think I can continue. Okay, Prime Manuel, that is good. Maybe a recap. A small recap is that we have come here, first of all, deployed our smart contract, which is our ERC20 token, and we have made it to 2 decimal places, and it is called descend.sol. So if I'm to descend.sol, yes, this is the smart contract. So I copied this address and I imported it in my wallet. When I go to Sepolia and under tokens and then 3 dots import, then I pasted the address and yeah, so copied descent.sol, copied address, and then I added my ERC20 address. Yeah, so here they're saying token has already been added because I've already added the token, and it is here DCT with 0 Decentraland tokens. Okay, therefore I also minted if I want to mint to this, before we go further, let me first continue. So I also deployed the smart contract of the token shop. So when you look at the descent.sol, it is to 2 decimal places as we have seen, and it is an ERC20. So when you go to token shop, here, this is in the rise up, the code. We started by importing the Chainlink aggregator v3 interface.sol, and we say that this aggregator v3 interface is used so much in fetching Chainlink data feeds, and for this we want the data feed of ETH to USD because we want to we want our token to be worth $2 worth of ETH. So whenever someone buys or sends ETH to the smart contract, it should give him tokens in the ratio of 1 of the token is equivalent to $2. In the ratio of $2 is equivalent to one token. Yeah, $2 of ETH that they have sent is equivalent to one token. And for us to know that this amount of ETH is equivalent to this amount of dollars, we need the aggregator v3 interface. And we say that for you to know more, you can come to the Chainlink oracles, and then this is the data feeds and getting historical data, or using data feeds. You can read so much about the aggregator v3 interface. Of course, we continued and say code and started the, we have the interface, which is the token interface, then the contract token shop. So aggregator v3 internal price feeds, token interface, public minter, and then the token price, which is 200. So one token is equivalent to 2 USD. The reason why we say 200 is because we gave our token price, our token, to 2 decimal places. So that means that here, for us to have one token equivalent to 2 USD, we use 200. If I change this to 400, then one token will be equivalent to 2 USD worth of ETH. Yes. So then we have the public, of course, owner, that's the address, and we have the constructor. So in the constructor, we have the minter, which is the token address or the address of the deployer, and we also have our price feed, which we get from giving aggregator v3 interface and passing in this contract. And we said, where does this contract come from? So this contract comes from the addresses of the Chainlink oracles. Again, it is under the data feeds. You go under the feed addresses, and then you see the price addresses. And we said that these are the different networks. So for Ethereum, since we are, so if you've like deployed on another network, taking a Polygon, then you will get a contract of USD ETH on Polygon if it is base, and many more. For those that have deployed on Lisk, I think Lisk is not yet listed, so we go to Ethereum. So you have the addresses on mainnet. So if you want to pick this data feed from the mainnet, let me say you deployed on the Ethereum mainnet, your token, and then so on Sepolia testnet, when we go to under ETH/USD, this is the smart contract. Copy it and then pass it to the aggregator v3 interface. 306 ETH/USD 306. Are we together?
Yes, we are.
Okay, so I take that silence as a yes, and then of course function. So we get the Chainlink data feed, and here I was stressing that these commas are not statements out, but they are actually part of the smart contract. So if I don't put this comma, I'll get an error. So because this get Chainlink data feed takes 4 parameters, the round ID, the started at. So since we don't have we don't need the round ID, we comment it out. It comma is not part of the comment. So initially this comma mostly is put here, so it's always there, but it's not part of the comment, though the other statement is commented out. So if you write this smart contract and you forget these commas, you will not get an answer. The last one is the one that doesn't have a comma. So in these parameters, which are 5 parameters, the round ID, the price, the started at, the timestamp, and the answered in round, we only need back the feed of the prices. Yeah, so this can all be gotten from reading the docs of the data feeds by Chainlink as an oracle. Then yes, so function token amount, this is what is used to, yes,
Okay. But my question is, does that mean that solidity functions cannot leave a parameter unassigned when you're calling the function.
So are you saying because of the comma?
Yes, because of the comma.
So this function is a Chainlink function. Though it is written in Solidity, it is Chainlink function, and it is dependent on how the interface was recorded. So yes, in this interface there were 4 parameters, and you take out what you need. So you might find that in your smart contract you need to use all the 4 parameters: the round ID, the started at. Maybe you want to know the price feed, the data price feed, from second A to second B, or from time A to time B, and things like that. So we continue, and of course we have the token amount to send. So this function calculates how much of my token should I send to this person who has bought, who has sent ETH to my token shop. And first what we do is, so we get ETH USD, we get first the Chainlink data feeds, from get Chainlink data feed latest answer, which is the function here, to get the price. Then use that price to convert the amount of ETH sent. We know that ETH is sent in, we have to convert it to its smallest unit, or that ETH has 18 decimal places. So we get this amount of USD's amount of ETH, which is the ETH that has been brought in, as seen here. So that means that the person has sent to us, and multiply it by the ETH USD, the price that has been gotten, yeah, times 10 power 18. It's essentially just converting the amount of ETH that has been given into its smallest unit, into USD. Yes. So now here, then amount of token, we get that amount of USD over token price times 10 into 8 times over 2. This is simply a way to convert this to a 2 decimal place. Yeah. 8 decimal places from ETH USD over 2 decimal places from token. Then we return the amount of token. And then this is one of the most important function, as you say, the receive function, that your contract cannot receive assets or tokens if it does not have the payable receive function. So the receive external payable ensures that your smart contract can receive this ETH sent to it. And yeah, here we take the amount of token, and it is to be the token amount, that the message of the token that has been sent, which is msg.value. Then we mint, we call the minter, right? And then we mint the amount of token that this person is supposed to receive. So we have the modifier only owner. We have to require that only message.sender, only these tokens are sent to the person who sent the amount. And this dash means if this is true, we continue. If this is not true, maybe some other address has intercepted, then stop the program or exit the program. Then we have also this very, very crucial function, which is the withdraw function. And the withdraw function is to give the deployer of the token shop the capacity to withdraw their tokens, the ETH tokens that have been sent to them during the token sale. So after that, we went to deploy, and we said here, when you go to deploy, you will see that there is token interface, because this had 3 functions. We were importing an aggregator interface, and we have the interface token interface. So The first listed is the token interface. Please select the token shop, and you cannot just deploy, because when I check on my deploy, it is even inactive. It is asking for the address of the token address, meaning that your ERC20 token. So I copy the address of the ERC20 token and paste it here, and then deploy. So after that, that's how we got our token shop smart contract. Hopefully we are together. Okay, so now what next? So next is we want to grant the token shop the capacity to mint on our behalf. Though we gave it the capacity to know our tokens, we have not yet given the capacity to mint. And when you open our decent token, which is the token address, it has all these functions. These are functions that are gotten from inheriting the ERC20.sol. So we have the approve, decrease, grant role, allowance. Then under here on the minter role, when we click it, we have a byte 32, which is this, which shows that this is the minter role. So we said I want to copy my minter role. So how did this minter role come about? So when you're deploying a smart contract, which is an ERC20, minter role can be given to any address, or it can be the deploy of the smart contract, depending on how you are doing it. So some of that is done from the Open Zeppelin wizard. Let's look at it. So here I can say mintable, and then access, I say roles. So I can give the minter role, grant role, minter role. So that means that I will have to, give the either the wallet that is responsible for minting, or and have it managed. But this is so, or I give it to a smart contract to be able to mint on my behalf. So in this case, this is my minter role, and I want to grant the minter role. When I come here to grant role, I have to grant the role minter role, which is Control V. So that's my minter role. To which account I can give it to an address to mint on my behalf, or I can give this role to a smart contract. In this scenario, I want to give this role to my token shop to be able to mint tokens on my behalf. Then I click transact. Because wherever you are writing to the blockchain, you have to sign with your wallet address, and it will incur gas fee. Today there is energy. Alright, so I've granted my minter role, and by the way, I can also mint. So probably Manuel, can you send your wallet and I mint you some of my tokens? Oh,
Thank you.
I think yes, Nakib, you can also share your address. And I mint for you some of my tokens in the Rise app.
So it's there in the rising.
So Manuel, this is your wallet address. I thought this was your
Sorry, sorry, sorry.
your deployed.
My deployed contract. My internet is slow. I have to check the list. Can I put it in a Google Meet instead?
Yes, you can put it in Go Meet.
Thank you. I'll give you some. I'll give you 2 tokens.
So okay, so Ronnie. Okay, let me start. Let me copy this so I can mint for yours some tokens from my deployed token. So here there is mint. I can say mint to address this, and then if I want to mint for 100 tokens, I'll press 100 plus two zeros since these two do the small places, and transact. So decent.mint. Uh, you see, most of the time when you're signing addresses here, you need to look at the methods. You could be minting, you could be transferring your assets out of your wallet. So yeah, take precaution. So I think I've minted for who? CE, yeah. So if you import my smart contract, the smart contract of my token, you will have those tokens minted in your wallet. I think I can also mint for Maria and Manje. So yes, I think okay, let me also mint for Manje. Yes, so what we want to do, we want to exchange our tokens in return for ETH. Yeah, so can query the name decent, and here on total supply we have 330,000, which is the mint for the 3 wallet addresses that have been sent. So now if we come here and in our token shop we have the withdraw function, we can get Chainlink data feeds. When we click on it, you see that this is now the Chainlink data feed for Ethereum USD, and yeah, this is of course to the number of decimal places. I think it is 18. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. And then Minter. So if I click on Minter, you can see that is responsible for minting some of my tokens from my address. And then token price. So the price of my token is is 2 USD. So if I need to get like tokens from here, I can get tokens by sending my okay, so I can buy token from the token shop. If I copy the token shop address, so let me use my wallet. I have this wallet, and in this wallet I have DCT tokens, but I have 0. So I want to be among those who buy. I want to buy some DCT tokens to hodl. There is some speculation that DCT is going to rise. So if I paste here the shop address, most of the time it will be given, and then so here, send, not my DCT. I want to send Sepolia ETH. So I want to come here and send. So I paste the address of the token shop, and then I send some Sepolia, have 0.02 or 0.3. Yes, I want to send Sepolia to this token shop and confirm. So when I send Sepolia, this Sepolia is going to buy for me some token, DCT tokens. So I've sent, and if I come back to the tokens, and I look at my DCT tokens, I have 27.82 DCT tokens. This is my purchase from the token shop, and it is automated. So isn't this amazing? So that means that you can deploy your smart contract, and when you change this, I sent 0. So ETH to USD so if I put 0.03, did I put 0.003 or 03? 03. Yes, I have 56 USD, and then I said 1 USD is equivalent to 2. My token is equivalent to $2. So I have to divide 56.09 divide by 2, and what do you get? I think when you divide that, you get this amount, 27. Yeah, you get 27 point something. Yes, is that true?
You said what?
56.09 divided by 2. So that means that my token will always cost 2 USD worth of ETH, no matter what. Yeah, this can also help you to regulate the inflationary nature of tokens, of how tokens have been going on recently. Okay, so I think with this you can deploy your token on mainnet, campaign for it, for people to buy it. It could be also another proof that to these people who have your token, maybe you're doing a crowdfunding, and whoever sends money to your smart contracts, they have the capacity to they get a portion of these tokens, and probably in the future, or if somebody like reaches probably 100 of your tokens, then they can have access to an NFT that really congratulates them upon their fundraising, upon being part of the cause. In any case, I don't know what your use case is, but this is one of the greatest use cases of Chainlink oracles. So when we are done with that, of course, you could even have an interface, but you can come to your token shop and then call the withdraw function to withdraw these funds to your wallet address. Or even you could program it when these funds withdraw themselves to your wallet addresses with time, in given time intervals. So that's it about one of the greatest use cases of Chainlink oracles and automation. And yes, we are just starting with it. So we can have a break. I need questions, and then we go on to the next thing. So for those that want to buy my token, I highly appreciate testnet Sepolia ETH. You can just send, let me share my contract, address. So token shop, so name and token shop address. Okay, so I think I should have an X, should have something on X. So let me take some pics. can shop. This is too tiny, but I want it to fit. Yes, so okay, so yeah, and what um, what is anodis x? Okay, I think for now I can look for my pictures. They always disturb me to get as we take the rest. Make pictures. Oh, where did I get them from the other time? Yes, they are here. This one and yeah. So my post. Yes. So that is it. So we can go to another topic. And yeah, for the remaining time, we can really have something around it. What does the whiteboard? It is here. It has served me. Miro.com. Someone has told me it is called Miro. Myra Kenda, Miro.com. Hopefully that is right. So are people still attentive or Prime? Yes, your hand is up.
No, sorry.
Okay, alright. So since my Miro is back, or Miro, somebody will want to bring back the alphabet. It is Miro. So we are going to be, looking at meta transactions. So I think for this we can look at scenarios. So maybe there are times when you want your DApp users to have a gasless experience, or you want them to use make transaction without actually putting something on the chain, or you simply want them to use your token. So these are called meta transaction, and this level will dive deep into how to design meta transactions, and also how they can be exploited if not designed carefully. So if you have used OpenSea, you've seen that there are cases where OpenSea can let you make listings for free. So no matter what price you want to sell your NFT at, somehow it never charges gas beyond the initial NFT approval transactions. So, and the answer for that is meta transactions. So meta transactions are also commonly used for gasless transaction experiences. So if you want your users to remain with the Web2 user experience, UX, while using a Web3 sort of product. And when I mean by gasless, it means that somewhere is paying for the gas. This could be you based on what you want your app to accomplish, or your business model. So yeah, there are many use cases. For example, asking users to sign a message to claim an NFT. So instead of paying gas, you can send a transaction to claim the NFT. There are other use cases as well. For example, letting users pay for gas fees with any token, as we've looked at it, or even fiat without needing to convert to crypto. So multi-sig wallets also only ask the last signer to pay gas for the transaction being made from the multi-sig wallet. And the other users just sign some messages. So our main aim is to look at how does it work, and how does it work. So meta transactions are just a password where the third party or every layer in this case pays the gas for the transaction on behalf of the user. So the user just needs to sign messages and not send a transaction that contain information about the transaction they want to execute and hand it to the relayer. The relayers are responsible for creating valid transactions using this data and paying for gas. Relayers could be, for example, coding your DApp to let your users experience gasless transactions, or it could be a third-party company that you pay in fiat to execute transactions on Ethereum, etc. At this level, we will do two things: learn about meta transactions and how to build a simple smart contract that supports meta transactions. I think we shall not go into the smart contract part because it seems the input is really amazing. All right, so yeah, we also have to learn a bit about security bug in the first in this, in how to do these transactions, but since we are not going to really focus on the smart contracts, yeah, we shall continue with that. So how does it work? We have looked at that. Digital signatures. So we have really been talking about how hashing works, and yeah, we need to understand the second concept of cryptography, which is digital signatures. So mainly a digital signature is a signature used to can a digital signature be a signature? So, but the concept of a digital signature is simply you send a transaction and then you sign on it that it is from you. So it's a second way of reinforcing the source of the transaction that has been sent. So most of the time we see ourselves, for example, when you're going to send a transaction, you sign twice. First is you just sign, and the second you allow the transaction to happen on blockchain. So the first time you sign, it is proof that actually the owner of the address is the one that is proving. Yes. So that sign that you do initially is called the digital signature. All right. So I think that can be understood. So like when we are deploying, you first allow the first time and then you deploy. Most of the time when you allow, it's like you are signing a signature to prove that it is actually the address that is approving. So digital signature is a mathematical way to verify the authenticity of a message. Given some data, a private key can be used to sign the data and produce a signed message. Then someone else who believes they have the original input data can compare it to the signed message to retrieve the public key which signed the message. Since the public key of the sender must have been known beforehand, they can be assured that the data has not been manipulated and its integrity is upheld. So yeah, we can have use cases of digital signatures, and digital signatures are commonly used when wanting communicate security and ensuring that the contents of the message were not manipulated. We've looked at that here. You send the original message while it is signed on, and if they decrypt the signature and then obtain the public key of you the sender, then it is a proof that it is from you. So digital signatures on Ethereum. So in the case of Ethereum, user wallets can sign messages and then the original input data can be verified with the signed message to retrieve the address of the user who signed the message. So signature verification can be done both off-chain as well as within Solidity. Yeah. So here in this case, the address of the user is the public key. So there are many ways you can really do digital signatures. So we can go back into maybe deep into understanding that concept. So taking a scenario that we need to build it up, where users can transfer tokens to other addresses without needing to pay gas, except just once for approval. Systems that themselves will not be sending the transaction will be converting the gas for them, will be covering the gas for them. Sometimes there are very many use cases. Sometimes you want your token to have relevance. So recent I see if you want to get some testnet tokens from Chainlink, you should have a link token. It's a way of enforcing the relevance of the link token, and in turn it raises the price of the link token. Or maybe you have a game and then you're already earning from the advertisers and you want the players to keep at it and keep playing while enjoying the promises of Web3. This is what you can also do. Pay for them gas and make everything seamless. So this design is quite similar to how OpenSea works, where once you pay gas to provide approval of an ERC 720 or ERC 1155 collection, listings and sales on OpenSea are free for the seller. So OpenSea only asks the seller to sign transaction when putting up a listing. After, when a buyer comes along, the seller's signature is submitted alongside the buyer's transaction, thereby transferring the NFT to the buyer and transferring the ETH to the seller. And the buyer pays all the gas for this to happen. So yeah, as long as you want to move gas around, maybe you want to increase gas, you want to decrease gas, you want to have a business model of allowing the abstracting the entire gas transaction, meta transaction is a thing. So you can, I'm going to share an article here where you can use to read this in depth. And I encourage us to really, keep engaged, keep interacting, keep online, talk about what you're doing. No one knows what you are doing or what you are capable of. People know that which we have put out. So this thing is refusing to really add things. I think my internet is low. So with that, my session is over. So any questions?
If it's okay, please put that link in the chat, Google Meet chat. So you can just log it in our browser and tell it so.
This one is here. So I'm going to add this in the Rise Up. Maybe you could read more about. So meta transactions go hand in hand with things that come around innovation that comes around it, like account abstraction, whereby there are these sort of Web2 like apps where you don't need to create an address. Probably you don't need an address for a gaming app. So just create a sort of login with email address, and then the email addresses are mapped and some things, yeah, on the address and things like that. So then the category of account abstraction. Other than that, I'm open for discussions. Yeah, let's have some discussions. How is the session? What have you understood? What intrigues you? You're going to create some token. Yes, yes, Manuel.
Hello,
I I think the volume is down.
can you hear me?
Manuel, your voice is down. Ronnie, yes, Manuel.
That's a problem like that.
I can hear you.
Well, this is Maria that
Well,
is using Manuel's
this is Maria
laptop.
that is using Manuel's laptop.
Okay, yeah, that session has
Okay,
been
yeah, that
great.
session has been great.
Actually, I didn't know that it was it was
Actually,
I didn't know
I
that
didn't know that
it was
it
possible to
was
import a token on the other. So I've learned that today.
it was possible to
And then I
import
was
a
also
token,
on that step
and
of
then I was also on
on
that
that
step
step
of
of
on that step
adding
of
my token to the
adding my
token shop.
token to the token shop, but
Unfortunately, Kara has
unfortunately,
checked
Kara has
and
checked, and
okay, I
okay,
literally
I literally
remain following up,
remain following
but
up,
the session is
but
okay
the session is
and
okay,
I really
and I
understood.
really understood. Thank you.
All right. Any other submissions? Ronnie, are you there? So yeah, any other submission about today's session?
Yes, I'm there. I don't know if I'm audible. Am I audible?
Yes, you are audible.
Hello? I think the internet is disturbing. Okay, so my question is because now we had set the price inside the code where you put like 200 because we wanted it to be $2. because the decimal data logic, you put the price will be fixed for that token because I don't know, my internet is doing me dirty.
I can hear you. Ronick, I can hear you. I think it is my internet. Hello. Okay. So, am I audible? Tracy, do you hear me? Pod number, do you hear me? Yeah. So, next month, we shall be starting seriously with incubation. So, yes, get ready for that. We shall be really um, starting with the incubation program. And what I mean by that is we shall have, in these times, we shall be pitching, we shall be discussing errors and what project each one of us or a group is working on. We want also to do a lot of things around building templates. We know that probably for dashboards we have these 5 templates that we have put down and we know how they flow. It has the light and the dark mode. So we shall be struggling to make sure that we have those templates where you can just plug in, because almost